Ever wonder how doctors figure out what a healthy heart really looks like, without the chaos of it beating? It's like trying to see a balloon's true shape after you've let all the air out. But here's the twist. That unloaded state is a gold standard for understanding heart function, diagnosing diseases, and even planning surgeries. The problem? Traditional methods to calculate it are like solving a Rubik's Cube with a blindfold. Slow, complicated, and way too data-heavy. So what's the holdup? The heart isn't a static object. It's a dynamic machine, stretching and twisting with every beat. At the end of relaxation, diastole, its shape is squished by pressure. But the unloaded state, when it's like a deflated balloon, is hidden. To study this, scientists use finite element models, which simulate how the heart's muscle deforms. But these models are like marathon runners. They take hours to process a single patient's data and need massive datasets to train. Plus, they struggle with weird shapes or blurry images. Enter HeartUnloadNet, a deep learning game-changer. Think of it as a neural network that's learned the language of heart geometry. Instead of brute-forcing calculations, it uses a graph neural network, GNN, to map the heart's complex mesh structure. Unlike regular AI, which needs fixed-size inputs, GNNs are like flexible puzzle solvers. They adapt to any shape, no matter how irregular. Here's the magic. HeartUnloadNet doesn't just predict the unloaded state in one direction. It uses a cycle consistency trick, inspired by before and after image generators. Imagine training a model to turn a loaded heart shape into an unloaded one, and then back again. If it can reverse the process perfectly, it's learning the real physics of how the heart deforms. It's like teaching a robot to ride a bike by letting it fall, but giving it a built-in balance beam to correct itself. The results? Mind-blowing. HeartUnloadNet achieves sub-millimeter accuracy with a dice similarity coefficient, a measure of shape overlap, of 0.986. That's 98.6% precision. And it does it in 0.02 seconds per case, over 100,000 times faster than traditional methods. Even with just 200 training samples, it maintains 97% accuracy. It's like having a supercharged calculator that's also a genius at pattern recognition. Why does this matter? Imagine trying to predict how a rubber band will stretch without any weight attached. That's the challenge scientists face when studying the heart's unloaded state, the relaxed, pressure-free shape that's crucial for understanding how it functions. Traditional methods. They're like using a ruler to measure a rainbow, slow, imprecise, and often missing the mark. Enter HeartUnloadNet, a revolutionary AI model that's turning cardiac imaging on its head. Think of it as a super-smart assistant for doctors, capable of predicting the heart's natural shape in 0.02 seconds, faster than you can blink. How? Instead of relying on time-consuming physics simulations, this AI learns patterns from data, adapting to any 3D heart model like a puzzle solver that doesn't care what piece you hand it. Here's the magic. HeartUnloadNet uses graph attention networks which act like a neural network's focus mode. It zeroes in on the heart's most critical structures, ignoring the noise. This mesh-agnostic approach means it works whether the heart is simple or super complex. No more rigid templates or guesswork. But how does it stack up against the old guard? Let's break it down. Traditional methods like PCA, a statistical tool, are quick but struggle with the heart's intricate movements, often missing the mark by up to 1 cm. Then there's inverse FE, a physics-based model that's accurate but glacially slow. HeartUnloadNet. It's 100 times faster and more precise. In tests, it predicted the heart's unloaded shape with less than a centimeter of error, 98.6% accuracy to be exact. Why does this matter? Picture a future where doctors can analyze a patient's heart in real time, spotting issues like weakened contractions or abnormal stress patterns instantly. This isn't just faster, it's a leap toward personalized, data-driven care. Of course, no tool is perfect. While it shines with healthy hearts, its performance on diseased tissue needs more testing. But the team's already looking ahead, aiming to model the entire heart cycle and add physics-based constraints for even greater accuracy. In a world where AI is reshaping medicine, HeartUnloadNet isn't just a tool, it's a glimpse into the future. A future where heart health is understood faster, more accurately, and with less guesswork. Thanks for watching. If you're curious about how AI is transforming healthcare, hit subscribe for more deep dives into cutting-edge science.